Imagine stropping yourself into a spacecraft, accelerating to nearly the speed of light. You fly through the cosmos for what feels like a short trip. To you, maybe a few years pass, but down on Earth, decades have ticked by. You step out of the airlock upon returning home, only to find your friends, your entire family, and even your own children are now elderly adults. This scenario is a direct consequence of the mathematics of Albert Einstein. For centuries, the scientific community operated on one strict assumption. Time was a universal constant. 1 second ticked away at exactly the same rate for you as it did for anyone else, anywhere in the universe. In the late 1800s, a young Albert Einstein began to question this mechanical view of the world, spending his days obsessing over the unseen mechanics of the cosmos. He eventually arrived at a highly specific childhood thought experiment. What would happen if I could chase a beam of light? By 1905, Einstein was working as a junior clerk at a Swiss patent office, spending his days at a desk evaluating designs for new gears and mechanical sorting machines. At night, he continued his private study of light, searching for a way to reconcile his observations with the known laws of physics. Through pure mathematical reasoning, he arrived at a startling conclusion. No matter how fast you are moving, the speed of light remains exactly the same. It is the absolute, unbreakable limit of the universe. This creates a massive logical problem. If the speed of light refuses to adapt, then the traditional laws of physics simply stop working. Einstein realized that because the light beam won't change, space and time must be doing the adjusting. The math pointed to an inescapable reality. As you move faster through space, your passage through time literally slows down compared to someone standing perfectly still. Time behaves as a flexible dimension that stretches, compresses, and bends depending on your velocity. We only experience time as a steady, predictable march because humans move incredibly slow. Our daily reality is a low-speed illusion. In 1905, Einstein proposed that space and time are an interconnected four-dimensional fabric. Placing massive objects like stars into that fabric warps the grid around them. That invisible bending, dragging objects toward each other, is what we experience as gravity. Pushing the math further, he found that matter and energy are two forms of the same thing, giving us the equation E equals mc squared. Because energy and matter are linked, a microscopic mass holds an enormous reservoir of power, the specific insight that would later make nuclear energy possible. At first, much of the scientific community dismissed him. The idea of an invisible, bending fabric of spacetime seemed like a mathematical fantasy rather than a description of the physical world. To prove his math was real, astronomers had to wait until 1919 for a total solar eclipse. They needed the moon to completely blot out the sun's glaring light, so they could observe the stars sitting directly behind it. In that sudden darkness, telescopes captured something extraordinary. The light from those distant stars curved around the massive weight of the sun to reach Earth, matching Einstein's calculations perfectly. The photographs provided the physical evidence Einstein needed. His math accurately predicted the universe's behavior, replacing centuries of scientific assumptions with a new set of rules. Today, we rely on these calculations to keep our world moving. The satellites powering global GPS networks have to constantly correct their clocks to account for time dilation. Otherwise, our navigation systems would fail within hours. His formulas also give us the tools to analyze the extreme gravitational pull of black holes and help us model the expansion of the early universe. By continually asking, "What if?" an ordinary patent clerk mapped out the invisible machinery that holds our universe together. Next time on Journey of Scientific Discoveries, we scale down from the vastness of the cosmos to uncover the microscopic molecule that carries the instructions for every living thing on Earth, DNA.
The discoveries that change the world.